So now these are two molecules, okay, in a gas molecule. In a gas, let's consider two molecules in a particular gas which is in a container. So now at each collision, so when these two collide with each other, okay, when they collide with each other, a moving molecule, okay, see it has a momentum. So when I say an object is moving, it has some speed, velocity, momentum, whatnot. There are many factors that determine the rate at which it is moving, isn't it? Right. So now it moves with a velocity mv. It moves with a velocity mv. Right. So now we are considering the ideal gas system. Yes. So when we consider an ideal gas system, what kind of collisions do they experience? Elastic or non-elastic?
For the ideal one, are you saying? Or, uh,
I,
yeah, is it elastic or like as little sticking as possible?
elastic. The collisions are elastic in case of ideal gas, right? Because the loss of energy is like almost zero. They do
Yeah.
not transfer their energy, right? So since the collisions are elastic, okay, the molecule it bounces back with the same velocity, okay, in the opposite direction, right? So that means what?
Yeah.
So here is an obstacle, okay. So what did the gas molecule do? It was moving in this direction, okay. So now there is an obstacle. As it is traveling, there is an obstacle. So what will it do? It will not transfer the energy. No, that will not happen. Instead, it bounces back with the same velocity. It bounces back with the same velocity, changing
Yeah.
the direction. Changing the direction. So since velocity is a vector quantity, since velocity is a okay, since velocity is a vector quantity, direction is very important. Now, okay, because you know what is a scalar and what is a vector quantity, right?
Kind of.
Scalar, they are direction independent, like mass. So mass, what is the difference between mass and weight?
Uh, is
Mass. So
or
when I
is
say
like
yeah,
what?
mass is like a crude. It's a crude parameter, okay, which is almost constant at any direction or any place. But weight is something that is dependent upon gravity.
Okay.
Okay, mass of the body is independent of the gravity and the direction. So when I say direction, mass acting downward is nothing but weight. So that is the difference between scalar quantity and the vector quantity. Since the velocity is changing and velocity is a vector quantity, there is a slight change in velocity which is denoted by delta V. Right. So this delta V is equal to an acceleration A. Right? It is equal to an acceleration A. So according to Newton's second law, force is always dependent upon mass and acceleration. F is equals to ma. So the force, when this force F is exerted on the surface area, okay. So the area, let us take the surface area A. Okay, this is the surface that we are taking, and we are exerting the pressure. Okay, we are exerting the pressure. So the pressure of the gas is caused by what causes the pressure of the gas? Let's see what causes the pressure of the gas.
Like from the different collisions, is it, or when he like?
Yes, yet, because that is not, you don't observe this collision kind of, this pressure kind of thing in solids, but you find it in liquids and gases, right?
Yeah.
You find it in liquids and gases. Why? Because of the intermolecular spaces, okay, they collide with each other more, randomly and more frequently compared to that of solids. So this is the reason why due to these collisions, there is something called pressure associated with liquids and solids, right? So the pressure of the gas is because of the collisions of molecules with walls of the container, right? So because of these collisions on the walls of the container, okay, there is
Yeah.
pressure exerted by the gas. So the magnitude of the, so now we are saying that collision is causing pressure. Now the magnitude of the pressure is dependent upon what factors?
Oh, like is it the weight or like the how or the mass of those
And how hard
atoms?
and how often. You know, you're throwing a ball to the wall.
Yeah.
Okay. So you want the ball to come back to you every time you throw.
Yeah.
Now, see, if you just throw it just like how you're throwing a stone into a water with that minimum, light, like very small number of force, small amount of force, will it
Yeah.
come back to you? No. You need a certain magnitude, you need a certain energy and force to be applied on the ball, okay, so that it comes back to you with almost the same velocity. The same velocity is very important because it has to cover the same distance to come back to you, right?
Okay.
So
Yeah.
the same with the magnitude of the collision, the magnitude of the pressure exerted on the walls of the container by the gas molecules is absolutely dependent upon on how hard the molecule is hitting the container and how often the molecule is hitting the walls of the container. Now, why does a tin, maybe a soft drink tin, it pops out when you take it? You don't have to open it, right? Right. Sometimes it kind of explodes, or sometimes when you or shake it too vigorously, what is happening? As soon as you open, it jets out. Right.
Yeah.
So what is happening? Why is that happening?
Is it because there's like a lot of pressure inside and then it gets like released
The pressure
through
is
the
being built because of the increased kinetic energy of the molecules. So
Yeah.
you are kind of shaking it. So what is happening when you shake? You are agitating the molecules. Thereby,
Yeah.
you are increasing the
Pressure.
pressure. Because why? As you're agitating, you're forcefully making the molecules hit the walls of the container.
Yeah.
They're hitting the number of hits, okay, and how hard they're hitting is how hard they're hitting is dependent on how fast you shake the bottle. How often, also how fast you shake the bottle. So if you're increasing the speed of shaking the bottle, the number of collisions increase, the pressure increases. So once when you open, it jets out, right? So
Yeah.
the magnitude of the pressure is dependent upon how often and how hard a molecule is hitting the walls of the container. The hardness of the impact of the molecules, when I say hardness, how much pressure is being built inside the container, will be related to the velocity of the molecule times the mass of the molecule. It means mass into velocity, mv.
Yeah.
mv gives us the impact or the pressure, okay, that is
Yeah.
being exerted, the magnitude of the pressure that is being exerted on the walls of the container,
Okay.
right?
Yeah.
Yeah. So this is about pressure. Pressure is dependent upon the number of collisions and how many times it is being, collided. It is being collided. Number of collisions and how many times in a second it is being collided determines the pressure of the molecules of the gas on the container. Understood?
Okay. Yeah.
Pressure. So the next temperature, let's see temperature factor. Next is temperature. So according to kinetic molecular theory, okay, the average kinetic energy of an ideal gas is directly proportional to the absolute temperature.
Mhm.
The average kinetic energy is like URMS, EK. Yesterday you have studied this, na? EK is equals to half MURMS, root mean speed. We have seen this formula yesterday, didn't we?
Mhm. Yeah.
Right. Okay. So kinetic energy is the energy of the body has the energy of the body, energy a body has by the virtue of its motion. That means, see, a body will have certain type of energy, certain amount of energy when it is at
Yeah.
rest. So that is called as potential energy. That means potential. Why do we call it potential energy? We don't know what wonders that energy can make the body do. Right? It is kind of in its hibernation state. Potential energy is the energy that is converted into kinetic energy once the body gets into motion.
Mhm.
Right?
Yeah.
Right? Yeah. So it is given by the equation half mv square. Right?
Mhm. Yeah.
So K is the kind. Okay, right. So as the temperature of the gas raises, so
Mhm.
when I'm increasing the temperature, when I'm decreasing the absolute temperature of the gas, the average velocity increases because the collisions increase.
Mhm.
Right? The kinetic energy increases and the object starts bouncing there and then itself. So what happens? The velocity of the individual molecules increase. When the velocity of the individual molecule increases, does the root mean speed increase or no?
Uh, as what increases is the individual speed increases.
Yes.
Did you say?
Yes.
Does the yes, because all of them are
Of course, the average speed increases. What is the average speed? It is the sum of the energies by total number of molecules.
yeah.
Right? So the average speed is dependent upon both the factors where both are increasing. So when
Mhm.
both are increasing, obviously the URMS or the root mean speed will definitely increase. Right?
Yeah.
So, so when we what happens? So when we say we have a temperature K. So at temperature K, okay, we have
Yeah.
the kinetic energy as half mv square. Okay, we have the kinetic energy half mv square. This is temperature. Don't get messed up. This is temperature.
Mhm.
At temperature K. Now what if I'm doubling this? I'm doubling the temperature.
Then like your speed will increase, right? So then
Speed increase by how many times?
uh 2 times or
V square.
oh
So
for
that
the
increases
oh
by 4 times.
okay oh
Plus kinetic energy is its velocity square. So when
oh yeah
velocity single unit of temperature, if it is square, it will be four
mhm
times units, right? So the
yeah
velocity
yeah
will increase by 4 times,
yeah
right?
mhm
So this shows that temperature as the temperature increases, the velocity increases, right?
okay yeah
The collisions with the walls of the container will transfer more momentum and thus more kinetic energy is now as the velocity increases, okay. Now as the velocity increases, I told you before, as the velocity increases, see it has to what is a gas molecule doing? Simple when it is in a closed container. When it is in a closed container, Okay, let's say it is first hitting this molecule. As soon as it is hitting this wall, okay, it changes its direction towards this wall. Now it hits this wall. So what will it do? It will move to this wall. Okay,
Mhm.
when it is hitting this wall, it will move to this wall. So there's a continuous collision. There's continuous collision. So let's say
Mhm.
per second there are 4 collisions per second normally at room temperature. Now
Yeah.
when I increase the collisions, sorry, when I increase the temperature,
Mhm.
this is getting doubled up. Okay, this is getting
Okay.
doubled up. The cycle that has to be done once, it is getting done twice. That means there are 8 collisions per second. Right. So
Uh-huh.
four collisions, if they are transferring some X joules of energy, 8
Mhm.
collisions, how much do they supply? They supply 2x joules of energy. Right. So as the number of collisions are increasing, the transfer of energy or the pressure exerted on the walls is also being increased. Right. Thus
Mhm.
temperature plays a very key role. Right. So if the walls
Mhm.
of the gas now see, I have increased the temperature, the collisions have increased, the pressure that is being exerted is also increased. Now what will I do? I will start cooling down the gas. If I just take the source of heat away. Right, now I'm starting to cool the gas. So what will happen to the velocity?
Um. mm,
I'm decreasing
Wait.
the temperature.
Oh, then it'll decrease.
Decrease. So the velocity decreases. Velocity decreases means pressure exerted
Then the pressure also decreases.
decreases because the number of collisions decrease. Then the number of collisions decrease because temperature depends on the average kinetic energy. So the
Yeah.
concept of temperature only applies to certain molecules of a certain samples of a gas, right? That means they should have
Mhm.
a definite because see, because the kinetic energy is dependent upon the number of collisions,
Mhm.
right? So if there is no minimum that threshold value. Okay, if there is no threshold amount of gas in a container, you cannot see the temperature factor. Now, if in this room, if I just let out 5 moles of gas or
Yeah.
2 moles of gas in this entire big room, will I able
Mhm.
to experience the collisions or the temperature rise? No, I cannot. Okay,
No.
but the same 2 moles of gas or 5 moles of gas, if I'm containing them to a very small space, then even that volume can create an impact.
Mhm.
So the impact is very important depending upon the number of moles of the gas because average kinetic energy determines the temperature of the gas.
Mhm.
Correct? Understood?
Yeah. Yeah.
Yeah. So the next one is molecular speed. How
Mhm.
fast a molecule travels. So we have studied that the relative velocity of a molecule depends upon
The the relative. Wait. What did you say?
the relative velocity of a gas molecule. What is
The
it dependent?
temperature.
Relative velocity. Temperature, no. Relative velocity is dependent upon molar mass. We have seen yesterday.
Okay.
Okay. Temperature is dependent upon kinetic energy. Kinetic energy is dependent upon pressure.
Okay.
Okay. Pressure is dependent upon number of collisions.
Okay.
Understood? Right.
Yes.
So here the relative velocity of the molecular speed is dependent upon the molecular mass of the gas.
Mhm.
So molecular sample of a gas as it has something called average kinetic energy that we have been studying since yesterday. The
Yeah.
individual molecules move at various speeds. So that is the reason why we take the average kinetic speed, right?
Mhm.
So some molecules they move fast and some molecules they move slow. So at higher
Yeah.
temperatures, a greater fraction of molecules are moving at higher speeds. So now see, I give you a graph. Okay.
Mhm.
Wait, I need to use two colors. So this is, let's say, nitrogen at 0 degrees centigrade.
Mhm.
Okay. So the curve is very steep if you observe. Steep it is. Right?
Yeah.
Now, this is N2 at 100 degrees centigrade. Right?
Mhm.
So
Yeah.
if you see, at higher temperature, the fraction of the molecules moving at higher speeds are more. If you
Mhm.
see, because the parabola has widened, the curve has widened. That means the
Yeah.
number of molecules that are traveling at an increased molecular speed have increased with increase in temperature.
Mhm.
Right? What is the velocity of the molecule possessing average kinetic energy? How can we calculate that? Now we have seen that as the temperature is increasing, the average kinetic energy is increasing. As the average
Mhm.
kinetic energy is increasing, it indicates that the individual molecular speed has increased. But
Yeah.
how does the kinetic molecular theory explain the average kinetic energy is related to the root mean square of speed, RMS. How EK is dependent on URMS. How does this explain? So we know that Ke is equals to half mu square,
Mhm.
right?
Yeah.
So this is different from the typical definition of an average speed, right? The first one that so this is average kinetic energy. Average kinetic energy. That means the individual speeds are calculated, okay, and then their average is taken. So this equation gives us the average kinetic energy of the molecules that are dependent upon temperature, that are temperature dependent.
Okay.
Understood? Have any
Yeah.
doubt? Sure. So what are the factors that we have seen? We have seen pressure, we have seen temperature, and we have seen the molecular speed.
Mhm.
Understood so far?
Yeah.
Shimla, is it okay if I stop the class here because I have someone at the door knocking?
Okay.
Or you want me to continue? Is it okay if I stop?
Okay. Yeah. So like this stop right like right now.
Yes. Can you come tomorrow at 6 a.m. tomorrow? We have school or
Um,
something?
I think I have to go somewhere tomorrow at that
Okay.
time.
Then
But
next Saturday, just ask your mom to know when you are free this week. So I'll just take the rest of the 20 minutes class that is left because
mhm.
it's only 7:40 now. 20 minutes we have, right? So the 20 minutes of the class I'll cover somewhere this week. Okay, just
Okay.
let your mom when you are free. Otherwise, we'll take it on Saturday.
Okay.
Hmm? Okay, thank you.
Mhm.